We've got an airplane traveling parallel to the ground and flies directly over your head. So let's just sketch really quick what's going on. So we are standing and we've got an airplane that flies directly over our head. All right, and it flies for a while in a direction. And we want to call that, and so it ends up, so at some time t. And we want a couple distances. So let's just look at that right there. We've got a triangle. We know that this altitude is 6 miles. So 6 miles. And s is the distance between us and the airplane. So us and wherever the airplane is. So we'll call that, there's our s. And then d is the distance the airplane has traveled. So there's our d. Find a function f such that s is equal to a function of d. Well, we've got a right triangle here. So the Pythagorean theorem says 6 squared plus d squared equals s squared. So s is equal to the square root of 36 plus d squared. There's our function of d. That was part A. For part B, we want t to be the number of hours elapsed since noon. Okay, this flies over our head at noon, and we want to find a function, g, such that d is g of t. So distance, well, that's just going to be how fast it's flying times the amount of time it's passed. So 600 miles per hour times how many hours, that tells us how far we've gone. So there's our g of t. And then for part C, we want our composition, f of g, and this is going to be a function of t now. So we're taking our g of t and plugging it in to our f. So that's the square root of 36 plus 600t squared. And what does this function represent? Given a time t, well, given time t, we plug it in to g, which gives us how far we've gone, and we plug that into how far the airplane has gone, and we find out how far the airplane is from us. Given t, how far is the airplane from you? That's given by this function. And I'll say that is given by f of g.